Alright, so all of the functions we've seen previously have been pretty basic. They've all been, cosine of x, or 3x squared, or sine of x, or some other trig function, or another polynomial. But they all had one thing in common, and that's that they were all just that x. There was nothing too complicated. So what would you do if you're faced with something more along the lines of cosine of x squared, or 6x plus 2 cubed, or, again, trig or other polynomial functions that aren't just x in the base or inside? So your first inclination might be that the derivative of cosine of x squared was just negative sine of x squared. And that's kind of the simplest path, but that's not true. The derivative of cosine of x is not negative sine of x squared. However, what you can do, or what you have to do, is called the chain rule. And that's where you kind of work your way inside and outside, because there's kind of multiple functions together. So, once again, with cosine of x squared, I'll just show what the derivative is, and then I'll explain why. So the derivative of cosine of x squared is equal to negative sine of x squared times 2x. So let's take a look. So we've got our variable x right here. But once you move out, that x is being squared, and then that x squared is being hit with a cosine. So when we take the derivative, we have to work outside in. You're kind of peeling back the layers. It's like the quote in Shrek, what derivatives are like onions. So you're going to take the cosine, and the derivative of cosine is negative sine. And that's where that negative sign comes from. Now, then you leave that x squared untouched. That x squared stays. That whole thing goes right there. But then you have to multiply by that 2x, which is the derivative of x squared. So first we took care of the cosine, and then we multiplied by what we had to take care of for the x squared. So let's do another example. The derivative of 3x plus 1 cubed. So first we locate our variable. There's our x. What is being done to the x? Well, that 3 is being multiplied by it, and there's also a plus 1, but when you take derivatives of constants, that plus 1 would just disappear, so don't worry about it. And then that is all being cubed. So, what do we do when we take the derivative? Well, the last stage was being cubed, so the first stage in the derivative is going to be to take care of that cubed. So, how do we take care of exponents? Well, simple. You drop it down, so 3. Leave the inside unchanged for now. 3x plus 1 squared. And now we take care of the inside. Well, what's the derivative of 3x? It's just 3. So we multiply this whole function by the derivative of the inside, or 3. So our actual derivative is 9 times 3x plus 1 squared. Another example, because that is still the easiest way to do these. What if we had something along the lines of f of x is equal to sine to the fourth of 4x plus 3? Well, where's our variable? It's x. What's being done to x? It's being multiplied by 4. What's being done to that? It's being signed. And what's being done to that? It's being raised to the 4th power. So we've got 3 layers in this problem. So we start with our outermost layer, which is the 4. So we have, I'll redraw, f prime of x. Didn't really get that. There's the prime. And the first layer, the outermost layer is the 4. So we have 4, and then we leave everything else unchanged. Sine of, and remember, now it's cubed because we dropped it down, 4x plus 3. Whoops. 4x plus 3. And now, what's the next stage? Well, the next innermost layer, or the next layer in, is the sine. So we have to multiply by times sine of 4x plus 3. Or sorry, that was wrong. Cosine. The derivative of sine is cosine. So we have to multiply by cosine of 4x plus 3. And what's the next layer in? It's the 4x plus 3. What's the derivative of that? It's 4. So we have to multiply that by 4. So if we combine things, we're going to end up with 16 sine cubed of 4x plus 3 times cosine of 4x plus 3. And that is the derivative of that function. So that about sums it up for chain rule. You'll see it a lot. It's going to show up in tons of problems, and we'll keep using it as we go on, so you'll get plenty of practice even in this. But it's really fundamental, and if you forget it, your answers are going to be way off, because you see, if you wouldn't have done that, if you would have just done 4 sine cubed of 4x plus 3, you'd be way off. So, see you guys next time.